Okay, so we're going to do an initial clean-out test for the Orange County project. We like to do these in our first set of testing in our baseline just to see if there's any problems. One of the things I'm going to note here is we've removed for our baseline testing, we removed the center splitter down this ramp. That's something that we've done a number of times in the past and with real good success with that. And once it's drained out, we'll take a look at how we tie that floor splitter directly back into this so it comes straight until it runs into the slope right here. This helps a lot when you have any sort of non-uniformity coming in the front. Now here with the pipes coming in and these gate slots get a lot of separation out here. We're going to find it also it simplifies construction considerably. So this is something that we've got a lot of experience showing it works real well. Okay, so we're going down through our testing here and water levels dropping. One thing we noticed, we've got a lot more water on one side of this ramp and that's due to the separation out here. We can see a ridge come right across there. If you look at this line right there, see that? So the sep flow comes in and it puts it over there. So we're doing this test now to see if anything needs to be done for a cleanout cycle. Hydraulically, in terms of the pump performance, everything was in criteria for baseline. So it doesn't need it for that. So this test is identifying whether we need to correct it for cleanout, and that'll back us up into whether or not we need to do anything out in here to redistribute that flow. So this is really what's identifying how much this needs to be corrected at the entrance. So as this drops down, we've got 12,000 GPM coming into here as our clean out, and we're draining. So we don't have 20 going in the outlet pipe, or I'm sorry, the clean out pump, but we do have 12 coming in and we're just draining the model. So that way it'll have this velocity be correct as it goes in. So we'll come back once that jump starts moving down. So we're still dropping. We may find, we've actually over here, we've got the, it's already built, the splitter that goes down through the center here. We like to actually test without that because if it's not necessary, we find the people who would like to remove that. But it may end up helping us redistribute this flow. So it could go back in, and that's part of a remediation thing. So we'll find out here. Okay, so we're starting to come down and we're just about to take the jump and start moving it down, and you can see we've got upstream flow along this side over here, and then you can see all the bubbles on the other side, so we don't have a very good flow distribution at all, which means it's probably going to shoot right down the right hand side and then not get a good clean out on the left hand side because we've got these bubbles that are actually coming all the way upstream, so we can see them on the right. You can see it's starting to move right there. It goes. So you can see the hydraulic jump on this side move down pretty well. It's going to start shooting right on down, and there it goes. This launches right down, and we've got nothing on the left side. So we need to get this flow redistributed. We've got too much water from the top here going over, and it's causing that to come back up. You can see it on the right where it's cleaned down, and on the left it's not. So this clean out will not work like this. It's going to clean really well down the right side. Nothing on the left. So we'll take a look at whether just a simple cure here or whether the splitter vein down there is going to be a better approach to this. When we don't have uniform flow hitting it up top here, a lot of times we dissipate this energy that's needed to go to the bottom, and we end up with a jump up top, a rooster tail we call it, and then it ends up not doing a very good job at the bottom. So we'll find out which one of those work better. This is just an initial clean out for our records here to justify why we either put the splitter back in or made any changes up at the top. If you can see, the right side cleaned out pretty well, the left side's not at all. So we're going to have to change that. It's moved almost all the way down now. You can see it really shooting right to the bottom there. That's what we want. But we want that it's not a real clean hydraulic jump because some water's coming over the top from this side. So we'll get this fixed.